Hello, everybody. We are back, and it is actually somewhat in the morning. Strangely enough, I'm actually on I guess, a good schedule, a somewhat normal schedule, where I'm actually sleeping earlier in the evening and then getting up super early, which probably still isn't great, but oh well. All right, so we're gonna jump right into this here with the formulating the method, and we're gonna go into the different parts of it. Go into some explanations of the different parts and maybe some terminology as well with some of this. So, without any further ado, we're just going to go ahead and go right into this. All right, let's start off with talking about some of the parts of the method section, and you'll see these within some of the studies that you'll be reading, in that they may even have headings for these. So, such as the participants. So that is the actual people that were taking part in the study, the subjects, the participants, the people that volunteered for the study, or possibly not volunteered. If it's an observational study, they may or may not know they're actually being studied, which can actually be kind of a good thing. If they don't know they're being studied, then they're going to act normal. If somebody is being studied and they know they're being studied, sometimes that can actually affect how they act and how they perform in certain activities. So, a lot of psychological research and even kind of behavioral research is very important. A lot of times, depending upon the study, that the participants don't necessarily know that they're being studied. Not all the time. Obviously, there's some methods and ways that the design of the study doesn't warrant the subjects to not know exactly what's going on. But anyway, moving on, we also have the instruments or any apparati. I don't know if they're apparatuses. I'm not exactly sure if the plural of that is apparati or not, but whatever you were using, any type of instruments that you were using. Now, you don't have to say, I'm using some brand of number 2 pencil or anything like that. You don't have to go down to that much detail. However, any type of equipment such as in our field, like how are you measuring VO2, what type of stopwatches you were using, what type of heart rate monitors you were using, how are you actually monitoring heart rate, what type of blood pressure cuffs are you using, if there's any type of blood draws or tissue samples, how is that being collected, what is the methods of actually getting those, is someone a trained phlebotomist? Something like a lactate or glucose is not necessary for someone to be a phlebotomist. Usually, sometimes the state laws can get a little bit funky with that, but for the most part, that type of stuff, like a finger stick, usually isn't problematic. But what type of instruments and what type of sampling materials are going to be using, and what are the brands? And with that, also putting in what studies have shown with that instrument beforehand. Are they reliable? Do they actually measure what they're supposed to measure? And once you describe the participants, how many there are, who they are they male, are they female, are they a mix, how many males, how many females, how old are they, how much do they weigh, how tall are they? All of these characteristics of the participants need to be stated within the method section. But after you get that and the instruments, what are the procedures? How are you going to measure the participants? And in what order will you be measuring them as well? And then what is the design and the analysis that you are going to be running with this? What type of design? Is it between subjects? So you're looking at this group, between this group, or is it more of a within design? Really, when you look at it, the whole purpose of the method section is how was the study conducted? Who, what, when, where, and how is pretty much what you're trying to answer. It needs to be thorough enough so that somebody else can take those same methods and replicate the study. That's the whole point of getting this information out there and writing this down, so that somebody else can say, hey, I want to try to replicate that study and see if I get the same results or similar results or possibly different results. And they need to be able to do that and to test what you did by using the same methodology. proper planning with this and the design, good instrumentation, the procedures, making sure the participants are a good representation of the population that you're wanting to study is going to help to eliminate some of the errors that can be involved within the scientific research. And it helps to eliminate any rival hypotheses that may pop up, or any type of weird scenarios that could come up, and maybe outliers as well. So there's two principles of planning. So less is more and simple is better. Another way of putting this is the K.I.S.S method, K.I.S.S, obviously. And that is keep it simple, stupid, or keep it stupid, simple, whichever you want to say. Making it easy to follow. Now, there are going to be times where there's some studies that are kind of big and almost grandiose, and there's a lot going on, and that's perfectly fine as long as you have the procedures in place and you know exactly what's going on during what periods of the trials as well as the study overall, and if you have enough help. The one thing is once you start mixing in a bunch of other tests and procedures, it could affect the timing of when those procedures are actually taking place, but also it could start to confuse you or another researcher that's helping out. And also it could affect the participant. If there's a lot of tests that are going on, especially if they might be somewhat invasive, finger sticks, so on and so forth, it may get to the point where they're just frustrated and they're almost ready to give up. I'll give you somewhat of an example. The participants that were in my dissertation, they were really, really good guys. They were all guys. And I was straightforward with them that we are going to be doing finger sticks at these certain periods of time. And they were okay with that, but there was a lot of finger sticks that were going on, a lot of finger pricks. And I've also been involved in a couple other studies where there was a lot of finger sticks as well as blood draws. We're talking about anywhere from a dozen to 16 finger sticks, plus maybe 8 to 10 blood draws per trial. So that's a lot of needles going into somebody. So somebody who isn't very good with needles, they're going to have some problems with that. So trying to reduce the amount of that is key, but also making sure that the participants know exactly what's going on and knowing that, hey, we need to do this because this is what we're trying to look at, not adding in extra stuff just for the sake of adding in extra stuff. There needs to be a purpose for that. And with that, with those blood draws and those finger sticks that we did, it started to get into the realm of almost screwing up our timeline a little bit, because we had to hurry up and get the finger sticks and get the blood draws during some of those studies. And we also at the same time needed VO2 and blood pressure. And I forget what else we were looking at. There were some psychological tests, and some of the psychological tests take like 5 minutes to do. So it can be tough to scrunch everything into one small time period, because if you're wanting to take all of those tests 5 minutes post-exercise, well, they all can't be 5 minutes post-exercise, because one of them is going to be lasting 5 minutes for one thing. And blood draws take a little bit of time. If you miss the vein or the artery, then you're kind of SOL at that point. So trying to keep it simple, keep it stupid simple. The other thing that I always say is, especially in a class like this, or any type of project you're doing undergrad, or even for a thesis, I guess even to an extent a dissertation, in general, you're not trying to cure a disease. You're not trying to cure cancer. Just keep it simple. If you do happen to find the cure for cancer during this, absolutely wonderful, fantastic. But the goal is to get a study done, go through the process of it, learn how to do it, and then throughout your career, then start to build upon either that or start something new that maybe is a little bit more grander after that. So just trying to keep it simple. and keeping it straightforward with the participants as well, and being honest with the participants about what you're going to be doing to them. Because one of the easiest ways to lose participants and to possibly even have some type of lawsuit is doing something on the participants that you weren't supposed to do. So again, keep it simple and also keep it honest with that. So moving on. So describing the participants, what type of special characteristics do they have, and what relates to the study? Is age and gender important? If it is, then that's something you need to list, and you need to list not the age of every single participant, but the average age, maybe an age range, what the gender was, what type of training level, if it's a training study, have they been training for the past 5 years? Are they completely sedentary? Whatever their training level is, that needs to be outlined as well. And also some other things to tell about the participants, the number of participants, and also in maybe the subcategories. If you're looking at maybe males versus females, how many males, how many females, and then what the overall total N or number of participants there was. And then during the study, you may lose some participants, and it could be for a wide variety of reasons. It doesn't necessarily need to be because they just quit. It could be someone got injured, someone had time conflicts, maybe they weren't necessarily fit for the study, whatever it may be, but there could be loss of participants, and that's something also to outline and maybe explain some of the reasons why the participants had to drop out. The other thing too is trying to protect the participants. And this goes into the health of the participants, but also their personal data. These are two important key factors here. Protecting the participants. The health of your subjects is the top priority. The safety is up there. If there is an unsafe practice, or it looks like the participants are getting ready to pass out or they're getting sick, focus on treating them at that moment, or if they maybe injured themselves somehow, focus on that. You can always redo the trial, whatever it is. This isn't that important to put somebody's health or life at risk. So making sure the safety is top priority within the studies. The other thing too is making sure that their personal data is protected as well. So if a participant comes in and they're ready to do the study, they went through the protocol of reading and you explaining to them what exactly is going to be going on during the study. They signed the quote unquote release form or the waiver or the consent form, whatever you would want to call it. We usually call it a consent form. They understand what's going on. There's going to be a name attached to that. There could be possibly a phone number, address, whatever else it may be, but there's also some personal data, age, race, gender, height, weight. There could be some other characteristics that are tied to that, but you want to keep that original document away from the public. Unless there is some way that you're getting that information out that the participant knows, but in general, in our field, we don't do that. There cannot be a name attached to the data that is disseminated amongst the general population, or it just can't get out. So normally that information is the original document. You keep that in a locked file cabinet or encrypted software, whatever it might be. And then usually you're going to be naming certain subjects, whatever you would want to name them, just some type of anonymous name. So normally what I would do is the first subject that comes in, they are S1 or subject 1. Next one will be S2, then S3, S4. So just name those subjects in either Excel or SPSS, whatever software you'd be using, S1, and then write down all the characteristics that you're going to be that they have. So height, weight, age, gender, blah, 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 whatever else. And then that's their data line. So you're writing down each of their trials and what the data is in each of those trials. Then subject 2 comes in, and you do the same thing with those subjects. But at no point in that file is there a name attached to it. You just know them as subject 1, 2, 3, 4, 5, 6, blah, blah, blah. So that's it. Now you can always go back and figure out who was subject number 1, you and the investigators. But the general public should not be knowing that, and it shouldn't get out. So it should be protected information somehow, somewhere. Little more detail in describing the instruments. So some questions to consider in selecting instruments. What is the validity and the reliability of those measurements, or of the measurements that equipment is actually going to be measuring? So the validity is it actually measuring what it's supposed to measure? The reliability is that when it's measuring what it's supposed to measure, does it measure it on a consistent basis? So is it repeatable? Is there a difficulty in obtaining measurements? There is certain equipment that you're going to be needing to get tissue samples. Is it difficult to get those tissue samples? How difficult? How much time does it take? Cost also plays a role in this. A lot of instruments and some of the data collection can get kind of expensive, especially once we get into things like tissue samples and blood draws and all that stuff. Also, access to equipment or the tests, again, the costs, the facilities that are available, and also the permission to use them. So I want to go into this just a little bit. This is beginning of July, and we still have equipment coming in. Thank goodness. Our lab is hopefully going to be built here pretty shortly. Right now, the equipment is in a girl's locker room. Some of it's still in boxes. We still have a couple pieces of equipment that's needed for us to put it together. But we have access to some of that stuff. We don't have access to everything that we would want to, but we have access to quite a bit right now, which is really good. The cost was a little bit, so we kind of went over that hurdle, and we have more cost prohibitive stuff that is in the pipeline, but we still need to look at it in the future. The other thing is permission to use, and this is something I want to go into because this is kind of like my own personal. I don't know if it's a beef. I'm not really sure. There's some programs across the country where undergraduates aren't even allowed to touch the equipment. I've even seen programs that the master's level students aren't even allowed to mess with the equipment. Only the PhD students are. I am completely different in this, in that I want you to learn how to use the equipment on your own. Now, I hope to be there while you're using it if you choose to do a study at any point in time, either for this class or in the future. But or actually somebody else who may be hired as well. But I want you to use the equipment. I want you to get experience with it. So you have permission to use the equipment whenever it is available. Now, obviously, there might be some times we need to set up to be able to use it, certain pieces, but I want you to be able to use it. So don't fear that if you're wanting to do a study at any point in time that, I have to wait for Matt to come into the lab or this and that. As long as it's available, I'm going to show everybody how to use it. And if you break it, if something breaks, just tell somebody. That's all that I care about. Because we'll get it fixed somehow. We'll replace it. We'll do whatever. The main point is the equipment is there for you to learn off of, and for us to be able to learn some of the practical applications to this stuff. And if you can't touch it, if you're not allowed to use it and touch it, then what's the point? Really, I've tried to explain that to other professors, not here, but elsewhere, and they didn't quite get that. In grad school, man, us grad students, man, we had free reign over the lab. It was great. Heck, we would come in sometimes at midnight and be working on pieces of equipment and testing out how they work and everything because we were kind of green. So, and we were allowed to do that, and it was fantastic. It was fantastic, and that's how we learned. It's how we learned how to do it. Now, I'm not saying I might be available at midnight if you want to come into the lab, but anyway, I'm kind of going off on a little ramble here. Let's continue on here with what should be presented. So the description. So including the validity and the reliability, bringing in other studies that have been done to test the validity and the reliability of those instruments. Any drawings, photographs, any sample items that'll be used, and any type of scoring methods that'll be used during this. Oh, one thing I forgot to mention too is knowing how to use the equipment. And that was kind of under the access to equipment or the tests, knowing how to use them. And that's something you just need to learn over time, knowing how to not just use them during the test, but is there any calibration that needs to be done? So knowing how to do that properly as well, knowing what the numbers mean, if there's an error that pops up, what does that mean? How do you fix it? So those are things that you just learn as you go for the most part. Just to be honest, there's some textbook stuff on it, but it's really getting your hands dirty and working with the equipment that's really going to teach you how to use some of the stuff. Moving on to the procedures. So what will happen? When, where, how much time? So, and this is in each of the trials or in the entire study itself. Also, is there any pilot data? Pilot data can be important. It could be 1-2 trials. It could be one participant that you're saying, hey, we're going to pay you or give you the compensation that we are giving everyone else, but you're going to be the pilot subject, meaning that we're going to go through the procedures and we're just going to make sure that we can do the study the way we want to. So when you look at a timeline of when you're taking the data, it looks good on paper sometimes, but when you actually have a real human being in front of you and you have finger sticks and blood draws and blood pressure and heart rate and VO2 and RER and all these other things you're trying to get, can you do it in that short little time frame that you were wanting to do? So the pilot data in the pilot study sometimes is to see, can it even be possible to do this stuff all at once, or what are some mistakes that could go on? From that, you start to develop what's known as an SOP, or standing operating procedure, so that you say, okay, after we do this at this time point, immediately we're going to go into this, and then immediately we're going to go into this. And if something messes up, then we're going to skip this one, and we'll move on to the next one, or we need to get this data. So even if we miss the stuff after that, so say we need to get heart rate and VO2. If we don't get blood pressure, that's totally okay. We'll just skip it, but we need to get this stuff. So if something happens with the equipment, or for whatever reason we're running behind, we still need to get these 2 data points, and that's it. The blood pressure isn't that important. And then from that, you could also say, maybe we don't even need to take blood pressure. Maybe it's not an important part of the study. So then the data acquisition, the recording of it, the scoring of it as well. So the planning, the treatments. So how long, how intense are they? How often are they going to occur? Is it separated by 1 week? Can we bring in the subjects day after day? Depending upon what the study is, you might be able to. Usually with something that's exercise related, especially if it's an intense exercise, usually a week is what's recommended for a washout period, especially if you're giving them any type of supplementation. Also, what's the participant adherence? How are you going to try to maintain a good amount of subjects and also motivate them to stay in the study? Then the pilot data, can participants actually do this then, kind of relating back to what I was talking about with the pilot data before. Then the appropriate treatment for the participants. So what is actually going to be appropriate to measure what we want to measure, that is also safe, and it's not going to put the subject at any type of undue risk. Moving on to some faults that could occur in the methodology and trying to avoid some of those. So looking at the details of the procedures, and this is where the SOP, or that standard operating procedures, can actually help with this. And some of this can be written down. This SOP can actually be written down, and we've even written down before in studies I've been a part of, where it was in a little binder of SOP of when things were going to occur, samples of how to go about getting some of the data if some things are missing or if the equipment fails or whatever it may be. And then also safety procedures in that as well. So specific order of things, the timing of the events, the instructions that should be given to the subjects. If there is a script that needs to be said to the subjects, that needs to be written out. Any type of briefings or debriefings to the subjects, and any type of safeguards as well. Again, the safety and the health of the participants is number one. Then any type of piloting of the procedures can help to reduce some of these faults and errors that could occur if some of these weird anomalies aren't worked out, maybe in a pilot study or pilot trial. So can you do this? Can the participants actually do it? One thing that I will say is I actually found this out. I kind of had a pilot study or pilot trial in my dissertation. This is one of the studies that I seen this in. Actually, might be the only study that I've seen this in. Somebody else had done this very similar study, actually pretty much the same methodology beforehand. I was just using different subjects, different age group. And I had basically mimicked his methodology, obviously. And when I did my first trial, we thought everything was going to go okay. But what we found out was that the exercise routine was actually too intense for the subject. So we had to reduce it just a little bit. So we had to go back and change some things with that. Now that subject, we told him, hey, we're going to still use your data to help us out, but we will pay you a little bit extra in compensation if you don't mind coming back for an extra trial. And he was totally okay with that. So that's where a pilot trial or pilot study could have been beneficial. We could have found that out before we brought in the actual subjects that we thought we were going to have the main data for. So, but again, important to make sure that the subjects can do it as well as the researchers can do it. Is there enough time available? Do the measurements work? Sometimes, no. In fact, we had, I'll give you an example of this too. I have lots of examples, and I apologize, but I've been through this. I've been through the ringer a lot, and I've seen some weird things in research. Some things just don't happen the way you want them to. Murphy's Law, right? There was a blood pressure machine that we had. So it was an automatic blood pressure cuff. Oh, this is going to be fantastic. We don't have to actually do it. We can be doing other things while this is going on, or it does it pretty quick, and we can just put it on, sit back, and let it go. Well, I didn't like it because it was giving us very strange readings. And I was even, after the first couple, I double checked it with my own, and then another researcher double checked it with their own measurement of it as well, actually getting the stethoscope and all that stuff. And it was way off. We were measuring blood pressures of, because they had just got done exercising. We were measuring blood pressures of like 130, 140 over, 70 to 80. And this blood pressure cuff, this machine that was supposed to be super accurate, was giving us blood pressures of like 92 over 60. It was way off, way off. So we ended up scrapping that. I think we ended up just throwing out blood pressure to begin with, because we just didn't have enough time to be able to do it. So anyway, do the measurements work? Do the treatments actually work as well? And the design and analysis. So design an experimental study in which the treatments cause the changes that are observed, not some extraneous variable, something you weren't looking out for, something that isn't part of what you were wanting to look at. You're wanting to look at certain variables. You're wanting to manipulate certain variables. You want that stuff to be causing the changes. You don't want something else from the outside. One of the obvious examples here in our type of research a lot of times is the weather. You don't want somebody to be running in the wind one day, and then the next day they're running with the wind. So the wind is at their back. Or one day it's 90 degrees out, and then the next day that they come in, it's 70 degrees out. It's going to cause some changes in the reaction and the response of the body. Heart rate, blood pressure, all different variables are going to be changing with that. So trying to minimize those extraneous variables that could be causing some issues with the data with that. And the design and analysis. So a little bit more on this, analyzing the data, looking at the correct analysis to actually do it, and then the interpretation of it. And some of this goes into learning how to use some of the software, either Excel or SPSS. Those are the two fairly common ones. You can do quite a bit in SPSS or in Excel, but SPSS tends to be the better, I won't say the better one, the bigger one that most people will use in the field. There's other ones too that researchers will use, but SPSS tends to be one of the more popular ones. And then establishing a cause and effect, if it's there. So the independent variable and the dependent variable should be related in some way, somehow, right? So you're manipulating the independent variable. It's causing the dependent variable to change somehow, some way, or possibly not. If it doesn't change, then we know that something isn't causing the change, and there was no significant difference, and so on and so forth. So, but we want to make sure that that variable is causing the change in the dependent variable. If there's an extraneous variable that's causing the change, then we have a problem. Or if you find out for some reason you didn't change the independent variable, so maybe it was a placebo or whatever it was, but the dependent variable did change, then you know that there's something else going on there. Something changed the dependent variable, and you have to go back and try to figure out what happened. Is there some anomaly that's going on? Is there some other variable that you weren't taking into consideration? You have to really kind of look at those things. So now when we move on forward with this, we're going to be looking at measuring research variables. So getting into a little bit more detail about some validity and just the overview of maybe some data analysis, just kind of a brief overview of it. So, but that was a little bit on the methodology and some of the things that you will see as you're reading through some of the studies, and some of the studies you've probably already read through. And if you go through a research study, these are the things that you will need to make sure to adhere to, and try to make sure that there are as least amount of errors as possible. There's going to be errors involved in almost every study. You want to just try to reduce as many as possible. There's going to be extraneous variables. These are humans. Well, unless you're dealing with animals, but that's a whole nother issue. But even if you are studying animals, rats, dogs, whatever it might be, anything that is living, anything that has a heartbeat, there is going to be variability. When we study humans, almost nobody is exactly the same how they're going to react, or how there's going to be maybe a certain adaptation that occurs long term. Everyone is going to be slightly different. So that's where you get some variance in some of the data, and also in the interpretation of what you've seen. So we just try to find some commonalities. We try to find some trends. There are some things that we see a major significance in, where most people will see a major change in heart rate or VO2 or blood lactate or blood glucose during certain periods of time. And obviously everyone's going to have a certain trend. Most of the humans are going to react similarly in terms of the trends, but how much they change, that's going to be variable. So, but keeping the errors down, eliminating as many extraneous variables as possible, and making sure that subject safety is number one. That's an important part there. So anyway, that was the methodology. If you have any questions, any comments, just let me know. If not, thank you for watching again, and I will see you next time here on, I don't know, in my blackened dojo, if you will. Maybe I'll show the behind the scenes at some point. They're just actually sound reduction blankets. I have one in front of me, kind of draped over my bookshelf in front of me, and I have like two of them here with PVC pipe. So anyway, that's that. So thank you for watching. All right, you want to see this? Oh yeah, there we go. I'm kind of blown out now, but you'll be able to see it. See there's the blankets right there, and you might be able to see. Yep, there's the PVC pipe right there. So that's basically what I have. I'll take the camera off and kind of show you at least a little bit of a roundabout of what I got going on here. So a little bit behind the scenes. If you're interested, I got a whole bunch of stuff here on the desk. There's some deer antlers there if you're interested. So, and there's the K.I.S. book kind of holding up one of the blankets. So just to reduce some of the echo a little bit. And then I got a light above me to kind of highlight on one head. But anyway, we will bring you back down here. The main reason that I have those again is to just try to reduce some of the echo that goes on, because this room gets a little bit echoey. And my goodness, the other thing too is when I do this, these blankets, like they're sound reduction, but they're also somewhat warm. You could probably use them as actual blankets if you wanted to. But I normally have an AC on in my fan as well, my ceiling fan, and it gets hot in here after an hour of just sitting here with these blankets surrounding me and the fan off and everything. But anyway, that's a little bit behind the scenes. I don't know if you're really interested in that. Let me bring this down because I look super blown out. There we go. That's a little bit better. Anyway, there's some behind the scenes. I don't know if you're really interested in that or not, but there it was. So thank you.